Hello and welcome to this short introduction in Antares, a free circuit designer and simulator tool. My name is Andreas, I'm the creator of Antares. In this video, I'm going to show you the bare minimum you need to know to start using Antares. Okay, let's start with installation. You can go to our homepage, which is antarescircuit.io. Can click on the download button, and here you see the three different installers we have for the three different platforms. Since I'm on a Mac, I'm choosing this Mac OS button. While it is downloading, let me quickly mention that we also have a first steps tutorial, which contains pretty much the same content that I'm going to explain in this video. So if you prefer working with written documentations, with texts and images, you can also use this page as an introduction to Antares. Okay, so download has completed. I'm just dragging the application into the application folder. Okay. Now I start it. A quick security question from macOS, which I accept. Okay, here we are. When you start Antares for the first time, it automatically creates a starter project for you, which is called My First Project. And this project contains a single circuit, which is currently empty. You also see that the project imports a library, which is the standard library of Antares. You can expand it, and you see here the components that come with Antares. For example, here we have the different logic gates. We have arithmetic components. We have flip-flops. We have multiplexers, and so on and so forth. When drawing a circuit, you will always go to the library and drag components into your circuit. Okay, let's start with the most simple circuit possible, which is a switch that turns an LED on and off. Okay. The components I need for this circuit happen to be in the frequently used folder. You see, I have a switch, I have an LED, and I have the three most commonly used logic gates. Okay, to add a component to your current circuit, you just select the component you want to add and then just drag it into the circuit while pressing the left mouse button and holding it pressed while dragging the component, and then just release it in the circuit. Okay, I'm doing the same for the LED. Okay, by the way, when you select components in this desktop tree, the component currently selected is shown here in a small preview window where you see the icon and the name of the component and a short description that explains what the component does when added in a circuit. Okay. You can zoom this view by using the mouse wheel if you have one. Just operate the mouse wheel to change the zoom factor. And you can also pan the circuit around by pressing and holding the middle mouse button while you move your mouse. So you can you have quite a lot of freedom to choose what part of the circuit is currently displayed. Okay. So the next thing I need to do is to make a wire between the switch and the LED. In order to do so, you see that these components have ports. This is an output port and this is an input port. And in order to make a wire between these ports, move your mouse over the end of the port, and you see that Antares shows a little green connection highlighter to indicate that that's a point where you can start a wire. Click the left mouse button, hold it while dragging the mouse around, and then move it onto your destination pin, and then release the mouse. Okay, now Antares has made a wire between the two components. I can select the component and move it around, and you see that Antares does an automatic relay out of the wire. Okay, you can also select the entire circuit and move it around. Okay. Okay, so far so good. Now let's simulate the circuit. Currently I'm in edit mode, which you see here. To start the simulation, I go here on this execute button and click it. And now Antares is in simulation mode. I can now click on this switch to turn it on and off, and you see that the LED goes on and off respectively. Okay, I can quit simulation mode by pressing again on this button, which brings me back into edit mode. Okay, to save our circuit, I have various possibilities. I can use this save button. I have an item in the file menu, save, but I can also use a keyboard shortcut. In this case, on my Mac, it's Command S. Yes, and now the circuit is saved. Okay. Okay, now let's make another circuit, something a little bit more sophisticated. Let's make a XOR circuit. In principle, this wouldn't be necessary because Antares already contains an XOR gate. You can find it here in the logic gates folder. It's this one. It's an exclusive OR XOR gate, but it is a built-in component, a basic component. And as you probably know from literature, and which is also described here in our first step tutorials, you can build logic gates from more basic components like ANDs and ORs and NOT. The XOR gate can be built by such a circuit consisting of two inverters, two AND gates, and one OR gate. And that's exactly what we are going to do now. Because we not only want to build this circuit, but we also want to build it in a way that we can use this XOR gate within other circuits as a component. We won't add switches and LEDs, but we will add special input and output components that allow us to connect this subcircuit with other components in its host circuit. So, okay. To create this new circuit, I will create here in my project a new circuit, which is currently not possible because I didn't save it. Okay, so the old circuit is saved, so I can open this pop-up menu with my right mouse button and I choose new circuit, and Antares will ask you for the name of your circuit. Let's call it custom XOR. Okay, and now you see that Antares has created an additional entry in my project. This one was the first circuit, and now I have this new circuit, and Antares automatically opened this new circuit, which you see by this orange icon. So the circuit that is currently open in the drawing area is indicated with a orange icon. Okay. I can switch between circuits back and forth by just double clicking on the node in the tree. Now I'm in my new circuit and click here. I'm now in my custom XOR circuit. Okay, let's build the circuit as indicated here. Okay, 2 inverters, 2 AND gates, 1 OR gate. Okay, I'm using the frequently used folder. Okay, I need 2 NOT gates and 2 OR gates. Let's make it a little bit larger. Okay, or AND gate, 1 OR gate. Okay, then I need a circuit input component. In fact, 2 of them. Okay, and 1 output component. Okay, you see that Antares automatically gives a generic name to these components, and these names must be unique within a circuit. To change the generated name, just click on the component and you see that here in the properties window you see all properties, most of which you can change, all properties of this selected component. In order to change the name, I go here and enter A, press enter, doing the same thing for this component and to give it the name B, and also for the output component, which I name O for output. Okay, and all we have to do now is wire up all these components. So this one goes here, 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 the AND go to the OR go to the output. And now I need to make, as you see here, a wire from this wire to the first input of this AND gate. Okay. To make a so-called junction, a wire junction, you have to press the Alt button while hovering over an existing wire. So press Alt, wait for the green connection highlighter, and press left mouse button, drag the mouse while holding the left mouse button to your target pin, and then release the left mouse button. Okay, so that was actually wrong. I should have connected A with the second AND. So undo and do it again. Alt, drag down here. Okay, quickly adjust it a little bit. Okay, also this one. Okay, and the same thing for input B, which has to go to this input of this AND gate. Okay, some beautifications. Okay, nicely aligning things. Yeah, perhaps so. Okay, save. Now let's test it by running a simulation. Press the Start Simulation button, and okay, XOR gate. If both inputs are 0, the output is 0. If one input is 1, then also the output is 1. But if both inputs are 1, the output has to be 0. So that's exactly the behavior of an XOR gate we are expecting, right? Okay, that seems to work fine. So this is kind of the internal view of our XOR component we are building. In order to make it usable as a component in another circuit, we also have to provide a symbol for this circuit. And Antares has a built-in symbol editor, and you can go to this symbol editor by pressing this button here, which is the symbol editor. So you can always switch between the internal view, the circuit, the effective circuit, and its symbol by going back and forth here. So this is the symbol of our circuit that Antares has automatically generated. But you can also change it if you don't like this symbol by, I don't know, making it a little bit larger, placing the pins, changing the symbol to XOR in this case. Okay, and this blue crosshair indicator is used to define the origin location of your component. So I typically place it on one of the input pins. Okay, so that's our symbol. Let's save it. And now we want to test it, of course, by adding it to a custom circuit. So I create another circuit. Let's call it test custom XOR. Okay, and now I add our custom XOR component to our test circuit, and you see that the symbol is exactly what we designed just a second ago. Okay, to test it, I have to add two switches. You can also use copy and paste here. I can also drag a component with a pin to another pin, and Antares will notice this and will automatically create a connection. Okay, and for the output, let's use an LED. Right, this. Okay, test it. Okay, seems to work. Okay, so since this XOR gate now is not a built-in basic component, but one with an internal circuit, we want to look into this circuit, into this XOR circuit, while this test circuit is our main circuit. I can do so, for example, by double-clicking on this XOR component and Antares will dive into this component, and while diving into it, it plays kind of an animation. Yeah. Up here in the drawing, you see a breadcrumb component that shows you where you currently are in your circuit hierarchy. To go back to the test custom XOR circuit, just click on this element of this breadcrumb to go back. Okay, once again, dive in and go back. Sometimes you want to see the insides of a component in addition to the circuit you are working in. You can open a subcircuit within an additional view by pressing the Alt key while double-clicking on your component. And you see that Antares now has opened this subcircuit in a additional view, which you can also zoom and pan like this one. And this also works during simulation. So you see that if I click a button on the main circuit, the signal, the one signal now goes into this circuit, and you see the signal also here in this open subcircuit. Okay. Perhaps I should also explain this component here, which is the simulation speed component. By default, Antares starts the simulation in a medium speed range, which shows signal colors. In this case, one is drawn with a light green, while 0 signals are drawn using black-green color. If I want to run the simulation as fast as possible, I can drag this simulation speed slider right to the right edge, and now the simulation runs as fast as possible. You won't see any difference because this circuit is so simple, but you will notice that Antares now doesn't use signal colors anymore, because if you run a circuit as fast as possible, then you would see a lot of flashing, color flashing going on, which can be quite disturbing. So use this range here, this speed range here, if you're finished with designing and testing your circuit and you really want to use it. During tests, I usually use this middle speed range, which gives me the signal colors. And there is an additional speed range down here, which runs the simulation even slower, and it displays even more information about what's going on. And in this case, you see that Antares plays signal flow animations. So in this speed range here, you can really see what's going on by following these signal flow animations. Okay, the last thing I have to show is how you create a new project. I mean, this project has been automatically created by Antares when you started it for the first time. I can close it. Yeah. Okay, you see now that the desktop is empty. In order to reopen it again, I go to File, Projects, And here I see a list of all my projects, which currently only contains my single first project. I can open it this way, and here we have it again. In order to make a second project, go again to this projects dialog, hit new, and enter the name of your second project. Okay, you can give a description of your project, and here you can add the library you want this new project to be based on. So this will be the library from which you consume components to use in circuits of your new project. A good choice here is the standard library. That's the standard Antares library we've already seen. Okay, well, so now I have a new project with a new circuit. I can add additional circuits like we already seen before, like this. And now, yeah, you can add flashes, you can add whatever you want, whatever components you like in order to build your circuit. Okay, I think that's all. This information should be sufficient for you to start working with Antares, to build your own projects with your own circuits. Of course, there is much more to explain. For example, scenarios and use cases, and creating truth tables with Boolean expressions and so on and so forth. But that would be too much for this video, which is supposed to be solely an introduction video. I hope you have fun with Antares. If not, if you are finding bugs or you miss features, you are very welcome to let us know. Just go to this page here, where you can learn how to report bugs and request features, which will be issues in our GitHub project. We are really happy if you do this, because this will help us make Antares even better. Okay, thank you for watching. I hope you have fun with Antares, and see you in the next video.